projectile practice. At the end of my last video, we just solved for the time. And we said that the time is the same in both columns. Part B of the question was how far from the base of the cliff does a stone strike the ground, which is this displacement right here, which is called range, and that's something in our x column. That's the displacement in our x column. And I ended that video very quickly by asking you if you could solve this. So, since you know everything in this column except for that, you can use any three of your kinematic formulas that'll work. I always try to use things that are relatively easy. And so what I'm going to do is I'm going to use the same equation, equation number 2. It's actually used a lot. I'm going to draw it in blue because it's a blue thing, and I try to keep doing that to cut down on any confusion. Here, it's in blue. We use this blue side. I know what the times are. I'm going to go ahead and plug some values in. We'll see what we get. Velocity was 15 meters per second. Put that in here. My time was 3 seconds. All this gunk goes away. It turns into 0 because my acceleration in the x is 0, so it all goes away. So we're left with 15 times 3, which is 45. This happens quite a bit. Does anyone know what this equation is right here? When you get rid of all this other gunk, what's left over? Delta x equals v naught times t. You guys know what that is. If you solve it for v naught, you get this, which is velocity is displacement over time. It's just v equals d over t. So that's what this is. So if you can get this part to drop off, which you usually can, then all you're left with is this part. Let's think about this. What is the ball doing in the x? Well, it's moving at a constant speed, right? So its speed is 15 meters per second. If it travels this way for 3 seconds, the displacement would be 45 meters. There's no acceleration. And if we were nasty, and sometimes we are, we could ask you to even graph that motion. So that would be like a 2-part, 3-part type of deal for a question like this. Wile E. Coyote is now in the real world. He was running off a cliff. Becomes a human projectile, although Wile E. Coyote is not a human. But anyway, it takes him 12.5 seconds to hit the bottom of the canyon. He falls to his cartoon death, and he lands 82 meters from the wall of the canyon. How far did he fall? Or conversely, how high is the cliff? What was his cartoon velocity as he ran horizontally off of a cliff? So this is the problem. So how do we approach problems? Well, we relax. We read the problem. We read it twice. Draw a picture. So I'm going to draw a cliff. I may not draw Wiley because I'm not a good artist. So I'll probably just draw like a circle or something to represent him. I'm going to put some numbers in there. It takes him 12.5 seconds to hit the bottom of the canyon, and he lands 82 meters from the wall of the canyon. So the 12.5 seconds is the time, right? Seconds. Now what's this part? 82 meters from the wall of the canyon. A lot of people don't understand that verbiage there. What does it mean he lands 82 meters from the wall of the canyon? Here's my picture. We'll just pretend the ball is Wile E. Coyote. Time is 12.5 seconds. He lands 82 meters from the wall. So that's a thing in the x. That's an x thing. Relax, read, draw. Draw a picture as best as I can. It's a cliff. Okay. Now, look at this. Make a chart. Make 2 columns. What are you going to put in your chart? How's your chart going to look? Go ahead. Put some numbers in that chart. Here's my chart. Take a look at it. In the x, I'm going to say that it has an initial position right here. That's 0. Final, we'll call positive 82. It's going to the right. We don't know anything about its starting speed or its final speed in the x. We know that the time is 12.5 seconds, so that goes in there. My a in the x is 0 because I'm turning off air, I'm turning off friction. So that's in the x. My y values, time is 12.5 seconds. My a is negative 9.8 because Earth is going to be pulling it down, force due to gravity. My initial speed in the y is 0 because as soon as Wiley clears the cliff, gravity is pulling on him the whole time. He will start to accelerate down towards the center of the Earth. There you go. how far did he fall? Or conversely, how high is the cliff? So what is that? Is that an X thing or a Y thing? Right? That's a Y thing. So we're trying to figure out how high is this cliff. Okay? It really doesn't matter which one of these you put as 0 and which is your question mark. Depending on what you're doing, one way, your answer will be negative. The other way, it will be positive. Typically, I say that if the thing starts up here, then that's my initial, and then my final is when it gets down here. So I'm saying that my final position when Wiley gets down here will be 0, right? And the initial is up there, so what is that going to be? I'm solving for initial. Now, you made a chart. Time to choose one of your equations, and you have to choose one of the columns. What are you going to choose? Blue column or green column? What are we solving for? We're solving for a Y thing. How far did he fall? Or conversely, how high is the cliff? So that would be a Y thing. We're solving for this, right? So I look at my 3 equations. I really want one that has displacement. I really want something easy. So it says displacement equals whatever. And in my mind, that is equation, right? Displacement. I'm calling this delta Y because it's an up-down thing. Okay. Displacement, right? Do I know V naught? I do. It's 0, right? V naught. Do I know A? Yes, I do. Do I know T? Yes, I do. I know all of these things. I can solve for my delta Y. So at that point, the physics is done. And now what you're going to do is math. You're going to plug some numbers in. So here we go. The delta Y is really Y final minus Y initial. And if it was delta X, it would be X final minus X initial. So in this case, our Y final is when it gets down here. When it gets down here, that will be 0. X initial technically is our question mark, but usually, I don't even usually write this half the time. I'm just going to say I'm solving for delta Y. All right. So I'm going to do my math. 12.5 squared times negative 4.9. I do 12.5 squared first. The squared is only being applied to this 12.5. Then I multiply by negative 4.9. I got negative 760 something. Of negative 765.6 meters. And so you could look at that as well. That's the displacement that he fell, right? If you think about this in terms of 0 minus something, you could turn this into a positive and say this is the height of the cliff, which is positive 765. And it looks like the question doesn't really care. They are going to accept one or the other. Okay. Now, when I know something, I can go ahead and put it into my chart. So that's 765 can go into the chart right here, and I know more stuff. This cartoon velocity as he ran off the cliff horizontally. So that's a key word right there. What is the velocity as he ran horizontally off of the cliff? Well, he came off the cliff like this. So they're asking us to solve for the velocity in the x. Which one do we solve for? Well, it doesn't matter. We can solve for either one. They're going to be the same because if we turn off air and turn off friction, then our acceleration will be 0, and we can solve for either one. So what equation? What do you think? Go with equation number 1 because, it's the simplest one, and sometimes it does work for things. In this case, you're going to get some nonsense, right? A is going to be 0. 0 times 12.5 is 0. And all you're going to get is something that says the V final is equal to V initial, which is true and not helpful. The equation used most often for projectile motion is equation number 2. And so I go here a lot. Sometimes people go straight to it. It doesn't always work, but it works a lot of the time. So in this case, our delta x would be final minus initial, which would be 82, right? So 82 will go right here. I'm going to solve for V naught. Right? This all goes away. Let me just do this real quick. And as all this cancels out, because our acceleration is 0 in the x-axis, and that all goes away, and we're left with delta x equals V naught t. We can solve for V naught. There you go. So there you go. Not a whole lot of variation. I can ask you to solve for time. I can ask you to solve for something else, and you probably have to solve for time first. I can ask you to solve for range. I can ask you to solve for height. And there's one other thing that's pretty tricky, actually. This is a tricky question. What would be the final velocity just as Wiley hits the ground over here? What would the final speed be? And that's a hard question to answer. What's the impact speed that he would have with the ground? Okay. So people, first of all, people who are just starting out will probably say something like, well, it would be 0. Because he hits the ground and comes to a stop. And that's not what I mean. I mean, just as he's about to hit the ground, just a split second, what is that speed? Okay. And then they're going to pause and they go, are you asking me to find final speed in the y? I know final speed in the x, and that's not what I'm asking you. That question would be, what is the final speed in the y as he hits the ground? I want to know, what is the final speed that he hits the ground with? What does that mean? To answer this question, what we'd have to do is we'd have to zoom in right here. We'd have to zoom in and see what's going on there. So I'm going to do that real quick. I'm going to zoom in as he comes down to strike the ground. Picture, he's going to come down and he hits the ground how? At an angle. Why? Well, I mean, he's traveling like this and he comes down like that, and he's angled downwards when he hits the ground. Why is that? Well, because he's moving some in the x and some in the y, and that would be, right? Now, some of you are going, well, there was a curve, Sharky. I'm like, well, yes, but if we zoom in far enough on a curve, you're going to see a straight line. And he comes in at some angle, okay? And so this can be a little tricky. What would we need to find here, right? Is there any way that we can take this and make it into a shape that is helpful? This is a vector. It is an arrow, but it is a vector. Vectors have 2 pieces. All vectors have 2 parts, and I can make this into a little right triangle. Notice I've drawn them in a certain way. This part of my triangle is blue, and this part is green, right, to correspond to the 2 different speeds. Okay? So, what would be the speed in the blue part? Well, remember, acceleration is 0 in the x. So our final speed in the blue would be 6.5. Which is what we found for our last problem. Here's what this question is really asking you. When I ask to find his impact speed, we are really finding this. You can call this V total, V final, not V final. You can call it V total. This vector represents these 2 combined velocities. And that's what we're really asked to find. That's why we're not really looking for anything on either side of the chart. We're asking for those 2 added up. Okay? And you already know what the velocity is in the x. So the only thing you'd have to do at this point is figure out what is the final velocity, put a big ugly looking question mark, what's the final speed in the y? Once you know those 2 things, you can just do Pythagorean theorem, to solve for the final speed. So the question is, you're in the y column, what equation are you going to use? Equation number 3, which isn't used a whole lot, but if you look at it, it could really work. V initial in the y was 0. We know what 2 is, it was a 2. We know what a is negative 9.8. We know what delta y is, it was negative 765. And so we could plug all this in, and we could solve for our V final. And remember, you'd have to take the square root at the end there. You could solve for that, and then once you know that, plug it in here and do Pythag to find what his impact speed is. That's a lot of work, so that is complicated. Thanks, guys.